Great. Oh, I don't quite like my voice with the microphone. Let's begin anyway. Thank you for coming. This is going to be a family-like talk, and many of you may know who I am. I am César Gallego. I'm an architect at Viva, and I am Daniel Hernández, SecOps and data engineer at I4S. We are colleagues. We're working in an innovation lab, and we're going to tell you about what we've been doing lately. And I don't know whether you're really fans of cinema. We are. And we are at a cinema actually here in Kinepolis. And this weekend, the Oscar ceremony awards will be given. And here we're going to tell you about a horror story, about a scary story. So when we chose the name for our talk, we were like, okay, so how can we talk about this in a sentence? And we got the inspiration for our title from someone who may sound familiar. Okay. So, many of you may know him. He's the great Moff Tarting that appears in the Star Wars trilogy, the good one. Not what they did afterwards, which is kind of crap. And this guy invented doctrine of fear for management. And when they eliminate the Senate, and at a meeting they ask him, how are we going to keep the order in the galaxy without bureaucracy? And this great guy said, well, fear will keep the systems in line. Fear to the Star of Death they've built, and that fear eliminates the need of a strong bureaucratic structure in place. So we thought about how can we use that fear to avoid doing tasks that we don't like, that are slow and that are kind of painstaking. Okay, so let's begin with this. Nowadays in software development, we're experiencing a very interesting moment. There's a clear trend of applications to be more distributed and to use instrumentation techniques that are increasingly more modern. One would expect that by doing that, the tedious task of reviewing logs would be something like this. Something attractive, efficient, silent, cool. But the sad reality, when we reviewed the logs, is this one. This is divergent, scary. In the place where you get the logs, sometimes it's drugs, and other times it's a car, sometimes it's in flames. And despite having to, or on top of having to manage all this, you need to look at what could be scary in these logs. This is the guy that scares me here. He's got a spanner in the shooting. He must be really confident. So let's talk about the logs. So, logs are written by humans, and regarding humans who write logs, I like to mention two things. They have a discipline that is different when it comes to writing blogs, and they have a different information context as well. So the guy below, the guy Python, may write wonderful logs, well formatted, that will have the shape you have not been able to connect to port 5432, because even though that guy may be very disciplined, he doesn't have any context of what is done in your company. The guy that may convert it into a log message with true information is the guy on top in your company who has a lot more context, and he may say, well, we couldn't store the user preferences, but if he doesn't have a discipline or if he's lazy, he'll just leave the message below. And you're like, okay, so there you have no information and loads of problems. So let's talk about monitoring today. These guys launched their logs with different formats and shapes to a central bus. Let's call it Kafka. So all the logs go through there with different features, and eventually they get to a data lake or to a data storage, data warehouse. Data lakes are usually more modern, with big data, with processing capability, and that might be useful We want to extract information from these logs. They all have different shapes, which may be tricky. We need to do a ETL for both formats because they share the formats and you may extract information. But in the worst case scenario, you need one for each application, which is a pain in the back. Once you get that, you feed your monitoring system with aggregates and rules, and if everything works perfectly with those aggregates and those rules, it may warn you that something's going on. Although, if that happens, it's going to ignore something and you're not going to detect it. But if everything goes well, this will be your detection time. In everything we do here, the ETL and feeding the monitoring system, which is like a white canvas, and doing the rules, is the IT tool. It needs a lot of work. You need to do the ATL, do the rules, do the aggregates, keep them, and do maintenance. If you're failing any of these things, you don't detect it, or you don't configure it well. The CEO of your company might get a memo at 2 a.m. on Saturday, and then you need to send out your CV elsewhere. So once you have a more or less established detection time, the opposite may happen, that you don't detect it, and if you don't, you need to do a post-mortem. And when something bad happens in your system, you need to go to that slow log system to find out what's happening. And when you do that, you're pretty much dead. Exactly. When this happens, you know, they've gone full throttle into your place, and you might or might not know. When you do the analysis, maybe you will be further ahead or something else happens, or maybe when they realize and publish it, and your reputation is damaged already. That analysis may take some indeterminate time. You don't know how long it will take because you need to analyze the zillions of logs you've got stored in that data lake with different structures, and the ETL you've prepared hasn't been able to extract the information you need, and your rules haven't been effective. Therefore, you need to build new rules, a new ETL, and that takes some time and effort, and it bears some cost. So these IT costs need to be paid with interest if there's been an attack and you didn't detect it. So when we do the post-mortem, you're already dead. So there's no remedy. They've gone in, there's no solution. Just to try that they don't do the same thing once again. I don't know about you, but I'm scared of being killed. It's a scary feeling, and when I'm scared, I run away. Fear keeps me alive. And so far it's worked. So let's continue with that strategy. But what is fear actually? Well, fear is not just a letter from the tax office in July. That's not good, but fear is that feeling of there's something going on, and you're like, well, you have a look and you're like, yes, something's happening. So first of all, you get scared and then you have fear. So when it comes to finding fear, we have a split into components. When we think of fear, we all know what it is, but the machine doesn't know what it is, so we need to teach it. And to teach what fear is to machine, let's begin with this premise, with this basis. There is a component of surprise when you notice something's going on, but you don't quite know what it is. You haven't really identified the reason. And then you look at something. All of a sudden you hear a noise. You freeze and you turn around and you're like, oh, a tiger. So that assessment of the information that you're obtaining when you turn around gives you some sort of feeling that may be positive or negative. And that feeling, positive or negative, is not the only thing you need, because the machine may have it, but we don't want it to be slow. If it's slow, we will get caught. So we are lacking another component, which is efficiency. Our siege weapons cannot just be fear and negativity. We're like Chrome, and we were his stock first thing this morning, so we are obsessed with efficiency. So we'll try to make that component into our system. And this is a strategy that we'll follow to build it. We'll need to do some reverse engineering for the monitoring alert system and process of the log. So let's begin. Here we need to do ETLs, that's necessary, but the current ETLs are really coupled to the logs format. The logs have a format, Apache has ones, the databases have another one, and we need to manage all that. So we need to become independent from that, because that has a cost, which are the IT tools we were mentioning earlier. And if we do independent ETLs from the format, then we have the other side of the ETLs, which is the information they eject. And we need to get them to extract information in a format that allows us to test with different models. Maybe we need different ETLs, as few ETLs as possible to try with different models. Why do we want to try with different models? Well, this is quite new. FEar is not easy to model, and therefore we need to try different models to check the results they render. On the one hand, for the feeling, or the surprise rather, and on the other hand, for the feeling. And when we get those results, we'll assess them and we'll check which model we keep. So which is the approach we'll have to try models and then assess them? We'll begin from what's simple towards more complex. From less complex models, more simple, to more elaborated and complex models. Why? Because we don't like the hype. Here is Indiana Jones fighting a machine learning algorithm that takes 6 or 8 hours to train with Google GPUs, and analyzes the logs like a machine, but they find a rusty gun that kills it, so it's worthless. So we want that gun. Maybe it's not that cool, but it's sufficient. So how can we talk about data capture without talking about the technologies we have set up? Well, the most popular one is the following. We have a massive logs bus. We could call it Kafka, but it's not Kafka. And we have a monitoring system that could be an Elasticsearch or a Kibana, which is not in this case. So what have we done? We have exported several logs groups, some tiny, mid-size or massive ones, to do the test. And what we were doing now, we said, okay, we found the perfect place to upload our detection service. We put it here in the middle, in the bus, we get the logs as we get them, and we detect what's going on. Okay. So our experiment need to have some basic line. We established several. We said, okay, we want a basic model to define whether there's some sort of anomaly. And then another one, which is paranoid. Everything is anomalous or wrong. Another one is very lazy. Nothing is wrong. And then we use mathematics and said, okay, we need to do something very simple that renders results. So we began thinking strongly, and there's an algorithm used for the detection of errors in banking transactions that is quite well known. That was our starting point. So here's the model that we're talking about. And let's talk about mathematics a little bit, and we all love them, don't we? But it will be brief. This is Benford's law. The Benford's law, the first digit law, states that this first digit here, in a set of data that is not random and big enough, may be predicted statistically. So it appears about 30% of times. This mathematical law is empirical, so the guy who discovered it does not have a formula to explain it. He just has reasoning and the tests. So Mr. Benford was not the inventor, he was another mathematician, but he tested it, he tried it out in banking transaction, in accounting statements, in logarithms, in rivers, and it was met all the time. They've even applied it recently for physical constant laws, basic ones, and this is always also complied with. So there's a statistic frequency. Non-random things have a statistical frequency, and this happens due to another law called equiprobability. In a set of statistical data with some probability, they kind of balance out. But once you have a criterion, they don't balance out, they go to different places. And that also happens with language. In Spanish, for example, we know that the most frequent letter in a long dialogue is E. But if you want to know that, in a dictionary that would be the A. Why? Because depending on the usage of the language, there is one or another trend. And and not just the first letters change, but in fact also the ones that are long tail, the less frequent ones, also change. They were different now from the 18th century. And since we write logs manually because we read literature, there's a statistics frequency that may be detected. So first of all, we do a ETL that counts the counters in a row: A, B, C, D, parentheses, spaces, and so on. So what do we do with that? We do statistics.
So we take all of those histograms and we pile them up, we calculate the average and the standard deviation, and with that we do what we call the character space. And we will use that later on to see how infrequent is one specific line doing the same thing by counting the characters. This is one part of our total model. As we mentioned, we have feeling, we have surprise and feeling. And that's what we're going to talk about now. He has told us how we moderate surprise with statistic frequencies, but we will have to moderate that positive or negative feeling or sentiment that we want to use to detect things that make us feel not so good. The goal of all this is that of those many logs that get to us through that bus, we want to filter them so that they only come up those that have something unfrequent or weird in the sense of negative, something that you have to take a look at, something because something that comes up every now and then could be normal, but something that comes up now and then and it's not positive needs to be watched. So how are we going to model that feeling? Well, feeling is different to assess. Everything seems to be going well. You think that there's no trouble, and then all of a sudden you realize that's not the case. How come? How do you do that? By analyzing the logs. We've stayed earlier on with the characters of the local content, and now we're going to take a step back and we're going to look at the words. We cannot detect feeling in each letters and the different characters, but with the word we do we are able to analyze sentiments. So we're going to do analysis of natural language, and we're going to use a library that's called Spacey, and we've chosen it because as opposed to other libraries which are available for NLP, this one is very optimized to be used in projects that are going to be used for production. It's programmed in Python, which optimizes the execution of the code a lot, and it processes very fast, and we want it to be fast so that the flow of logs does not overflow the system's capacity and we start having a backlog. So what are we going to do with the spacing? So far we're going to divide the message in the words, and we're going to store them separately. So each log line is, and we're going to store the words separately. What for? Well, so that each word can be scored and given a score of as to how positive or negative it is, based on the information given by the dictionary that have previously been scored in that sense. Those dictionaries whether or not you have to check with experts in the specific context of security, we're just using dictionaries that are available in internet that are often used for the analysis of social networks. For instance, in Amazon, often to see if it's positive or negative, and give you the review. They use that. They give you a score. So it's a list of words that if it's, for instance, if the word good comes up, then it's positive. If it's a mistake, then it's negative, etc. So that's what we're going to do to have a general idea of whether it is positive or negative. The goal in the long term or in the middle term really is to have a dictionary that contains words that have a negative connotation, specifically in the field of security. But so far we're going to stick to this dictionary, and we'll see how it works. So evaluation, what have we evaluated without being too specific about our results, because we cannot do that. This is the assessment or evaluation that we have got. There is quite a lot of fear, but we have assessed each type of model that we've used, for instance, the statistical one and others that we have used to, as a reference, because and then we have checked with the security expert and we've asked him, how do you feel about this? And he said, this is good, this is bad, this is so-so. And this was our first assessment. We have tried neural networks to see if we could teach them to detect the infrequency, linear regressions, and we've also tested generating but the improvement of these alternatives was not enough to defeat our reference compared to the time it took, because the time of statistics that we were using was incredibly fast. For instance, the logs of 1 day and a half of the pre-production environment are dealt with in less than an hour, and there are a lot of them. So with this taking time into account and seeing how each model has worked, this is the reason why we decided that the statistics and the sentiment of or feeling one were going to be chosen, because we in our department work with the agile methodology. So what's important is to have something very fast that allows you to contribute that value in an iterated way and increase that value that way. And this would be meaningless for us if we were not going to use it for our production system. So everything we do is attempts to be useful and to make our lives easier, rather than staying in a drawer or in a repository. So as we've said earlier on, we want to link this to the bus, to the log bus, to have them to analyze them. So we have to read that log bus and process all that information. We will apply the models that we have assessed, or the ones that we have chosen, the ones that have been more effective, but that will be dynamic, will keep changing. The result of the current models could be improved, and we will make progress in that direction. On the other hand, what this service is going to provide, and that you will see now, is on the one hand scoring of the fear detected in the system at this point in time. As Cesar was saying, it takes just a small part of a second to do so, and 15 minutes is what it takes. It's 10 megas, and it takes some 10 seconds, and out of those, 8 or 9 are to do with the Docker image, because if we ran that directly in Python, it was even faster. So on the one hand, it's going to have in real time of the fear detected in the system, and on the other one hand, the specific logs that we cannot show you because we've done the tests with production data, and there are IPs there and everything, and we don't want to get in trouble, but we're going to have those 2 points of information. And now it's the time of fear. We're going to take the leap of faith. Cesar will do the demo. We're going to show you something that you can get your hands on. Can you roughly read it? Maybe bigger. So these are the libraries, our fields that I'm going to go over quite quickly. Some embarrassing things over here, but what I want to show you, we have assessed 2 public dictionaries before doing our own, because it's a lot of work, and the 2 dictionaries or lexicons that we have chosen are here. We're going to publish that in GitHub for you to take a look and for you to assess it, and also the service, so that you can execute it. And I encourage you to do it, because you get surprising results. We thought this was not going to work, but we look at the results and we're impressed. So back to the dictionaries, lexicon, and Senti-Warner. So there's a lot of data crunching here, but there is a graph here that I like to discuss in detail. This is the feeling detected in a group of logs. You can see to the left how lexicon is the blue line. It's like hard steps, whereas Senti-Warner is more nuanced. So we decided to choose Senti-Warner because that sort of feeling comes earlier, so it allows us to be warned not when things are really worrying, but when things begin to feel wrong. So to the right in the distribution, you can see how most of the things that score in both are neutral. And that's one of the things we want to change. It cannot be that the feeling of the machine that has to be scared when it sees things to do with affecting security, that it should be neutral. So we have to change the dictionary in that sense. And now we're going to look at something that's really great. Here we can see how in a positive and negative way. Matched is slightly positive, request score is twice slightly positive. Then dead is negative, we don't know why. Anomaly negative, I is negative, um, error is negative, and pit is negative. That's why we want to use another dictionary closer to security. But this is a message from sentiment, and if we see how lexicon scores it, it gives it a -1 in error, warning, and anomalies. So one has a slightly positive and a slightly negative feeling, and the other one is clearly negative. So we like the one that's earlier in its detection. And the analysis frequency, here we turn things around, and this is the characters space generated. You cannot look at the characters or you cannot read them properly, but for each one it gives you the central point, which is the average, and the upper and lower lines are to do with deviation. So when we compare that, what do? We get the scoring of the characters and we compare it with the character space. When you have a lot of red points to the upper right and the ones that correspond to the format, because they are the first ones, because they are the more repetitive ones, they are not there. So a mess, that's clearly anomalous. Here, this is not anomalous and everything is closer to where it should be. So we have to say how we calculate anomalies. For all those dots that are within the standard deviation, we put a 0 there. And those that are outside, we put a 1. We don't care about the distances so far. We'll see later on. And then for each one of these messages, you're going to get a right of 0, 1, 0, 1, 0, 1. And how do we estimate for that line the percentage of anomaly? We have a synthetic indicator, which is the average of those zeros and one, which is always going to be between 0 and 1. If the message is 1, that's a huge anomaly. No character is where it should be. If you have an empty line, that it tells you this is a huge anomaly. But if you give them something formatted and with beautiful words and with a date, then it's not striking. Why is so? Why does it like it? Because it has the same format as the other messages. And why do we insist in comparing it with other models beyond it being our baseline? Well, it has a certain dependency on the length of the message. If you have an empty message with 0 characters, it's going to be very anomalous. But 4 logs, which, as we've said, are very repetitive and non-random, works very well, because if somebody makes a mistake in formatting the logs or sending a message that it shouldn't send, or it doesn't capture an exception, well, this comes up very well, and you get very peculiar messages of people who are misbehaving all over the place. This is one of the evaluation matrices that we have with those who are in the talk. to assess the frequency model about which values move, the average, the standard deviation. But this was not enough for us. What did we want? We wanted to model fear in such a way that it can be a feeling that it's alive. And so far, we've managed that the machine has a certain resistance to fear. If they start seeing anomalous messages, it gets used to them, and the threshold, the fear threshold goes up, so that it filters a lot more, and it shows you only the messages that look really bad to him. So we're going to do a cut of check demo. What are we executing here? Can you see it? So we've Dockerized it because everything that's executed in a distributed environment like the one we have should be in Docker. We'll give it a name, and to simulate the Kafka, because it was huge to set up a Kafka for the demo. If you're scared with a container for a demo, then imagine with the Kafka. So we're doing it this way. We include the message within the model, and we see what it looks like or what it says. I say hi. Sorry, I've done a cut. It takes a while, and this is because it's starting up all the things that Spicy needs in order to do the synthetic analysis of the word, and that takes a while to wake up the model, and then it tells you how surprised it is to see this line, and the feeling hola is a neutral, generates a neutral feeling or sentiment, and surprise 98% anomalous. So you give them a word that they haven't seen often in the logs, then it wonders what this is about. If you write, hi, this is longer, it will still be very surprised, because if somebody has written in the bank logs, hi, this is longer, I would be surprised as well. But it hasn't said anything. It takes a while because it's using the backrise, the version, and it has to wake up the servers and then read the dictionaries, and then it does the assessment. But in the version, that's not. We were modifying the script yesterday, and perhaps something is not working well, but we have here, it takes the logs, it takes them to the computer, describes them in a file, then it formats the results in the standard output, and then it tells you the total of logs, the ones that they found as anomalous and the ones that have scared him. This takes some 30-40 seconds because we're talking about 15 megas of logs. But I don't think it would take a minute to start. We have not shown you the script that does the training, but basically reads the file, it calculates the character space, it trains the model, and then it allows you to execute. And the model changes every time you execute it. So with the data we're given it, fear is quite high because one of the first lines is quite scary, and from then on the level of fear stays around 95. And how do we calculate the level? Everything that's between 95 and we apply the standard deviation below. It's what we show as anomalous, and with that we do the sentiment scoring. There's a worrying word because there's a -6 and another -6. We filter the words because of the IPs and that we could not show here. But everything that we're showing here, so out of 13,000 logs, we get 205 that we will have to take a look at, which is about 1%. And that's quite a lot less information to process when an analyst should check if something has happened in the system. Okay, we don't have any more time. Here we upload the character space, but this is what we have surprise check, which is a statistics model. We've decided to use this statistic and surprise system because both in execution and training they can be done in streaming. You can have it in your pipeline of deployment for training, and then you can have it in production, and the whole statistics that it needs underneath is calculated in streaming. And with that statistic of how scared it is, it's how the thing will react later on. So what's left? We've prepared this further talk, but we have other plans. There are more things to be done. We want to improve the infrequency detection models to calculate that distance to the average to see what how far it is from the standard deviation. Another one is the vocabulary to get data sets that are contain that refer to the context of security, but not only security, because we've realized that this can be applied to any context. You can get weird stuff coming from security, but also in functional areas. There are keywords that if a functional analyst says that they realize that this is not working as it should, and then optimization. That can also make this to work faster, and because the volume is huge, and there are very heavy architectures that deliver an incredible amount of logs, and the growth is exponential right now. And we also have to say, well, test it. We're going to publish it. These are Twitters for you to get in touch with us, and I encourage you to test it because you will find surprising things. We were very struck by what we saw, and this is the blog. We are like an innovation umbrella for all the innovation done in the bank, and we do great stuff. We've recently delivered an article from and if you test this, please let us know how it's worked. Your feedback is very interesting for us. Feedback, ideas, or even effort. All the code we are going to look into because it goes to the GitHub of the bank, but it's going to be open source. You will be able to use it thoroughly, and we encourage you to test it because we believe this has many opportunities, opens up many opportunities, and we want you to benefit from that. And we won't take any more time because Chema is waiting for us until we're done. He cannot start his talk, so thanks very much.
¿Preguntas? ¿Alguien?
Questions? Okay. We're going to make a draw in the other room. It will be shown here through streaming. Do the speakers also get to participate? If you've registered, yes, but you are.
El sonido de la otra charla ya.